Welcome back, Year 5. I hope you enjoyed your long weekend. Today we're continuing our work with multiplying decimals, but today we're also multiplying them by 100 and 1,000. So our learning intention is to use our understanding of place value to develop fluency, that means accuracy and speed, in multiplying decimals by 10, 100, and 1,000. You're going to notice that today's video has a different style. You're going to actually see me working things out on a little bitty whiteboard in my room. Well, tell me in the comments below if you prefer this style of watching me work things out and talk you through it, or if you preferred the old way where I had worksheets up and edited the video so that you could see my thinking to go along with it. Just write me a comment below so I can know how you prefer to see things. Alright, so today we're looking at multiplying by 10, 100, and 1,000. And once we've done that, it's going to be very easy to understand how to divide by 10, 100, and 1,000. So just as a quick recap, last week we looked at multiplying by 10. Let's say I had the number 9.6 and I wanted to multiply it by 10. We learned two ways of looking at this. Well, first of all, if you're going to multiply something by 10, you're shifting it one place to the left. Because as you move to the left in terms of places, they get 10 times bigger. So it takes 10 ones to make 10, 10 tens to make 100, and 10 hundreds to make 1,000. So each place over is 10 times bigger. So if I plug in my number 9.6 to make it 10 times bigger, all I have to do is just shift it one place over. And it becomes 96. This makes sense because in the number 9.6, it has 9 ones. If I take 9 ones and multiply that by 10, I know I get 90. And in my final answer, look, 96. This 9 is now worth 90. So I know it's 10 times greater than when I started. The other trick we learned for multiplying by 10 is that you can think of it as moving the decimal point. Are you really moving the decimal point? No. The decimal point is always between the ones place and the tenths place. Always, always, always. But a nice trick for figuring these out quickly is just to say, well, the decimal point appeared here to start with, so if I move my numbers one place to the left, it's going to look like the decimal point moves the other way. So it's going to end up one place over. So it ends up here behind the 6. And in the number 96, look, the decimal point is after the 6. But what about if I need to multiply by 100 or 1,000? Well, when we multiply by 10, we move everything one place because the number 10 has one placeholder. How many placeholders are there in 100 and 1,000? 2 and 3. So when we multiply by 100, we're going to move 2 places. And when we multiply by 1,000, we'll move 3 places. Let's give that a shot. I'm going to take a different number. Let me wipe my board clean. Let's use the number 4.723. And I'm going to take that number and multiply it by 100. All right, 4 ones, 7 tenths, 2 hundredths, 3 thousandths. How many times do I need to move it? Well, remember, I'm multiplying by 100, 2 placeholders, so I need to move my number 2 places. 1 place, 2 places. My final answer, 472.3. I can double check this by seeing what happens if I were to move the decimal point. So it started here and it needs to move 2 places. 1, 2. My decimal point should now appear between the 2 and the 3. And look, it does. I also know this makes sense because I started with 4 ones, and if I do 4 times 100, I get 400. Is there a 400 in my answer? Yes, 400, 400s, followed by the rest of the digits. Remember, the digits always stay in the exact same order. Let's try another one. This time we're going to multiply by 1,000. Let's do, I like the number 8. 8.63. And we're going to multiply that by 1,000. All right, so let me clean off up here as well. 8.63. All right, how many places do I need to move this? Well, oops, I want my red marker. I've got 3 placeholders in 1,000, so I need to move it 3 places over. 1, 2, 3. What do you think? I see 863. So is my answer 863? No. What about right here? There's nothing in the ones place, but can I just leave it blank and just pretend it's not there? No, because the decimal point comes after it. So I have to put a placeholder here so that it's clear that my decimal point would fall here. Otherwise, my answer is going to look like 863, and that's not what it is. It's 8,630, and there's no ones. How do I know that this is correct? Well, I can double check it. Remember I said it needs to move 3 places. My decimal point was here, so I'm going to move it 3 places the other way. 1, 2, 3. So my decimal point would be over there. That's my time sign, but there's no other digits in there. If my decimal point falls there, that means I have to fill this space with a 0. Also, another way to know that this must be the correct answer is that I started with 8 ones, and 8 times 1,000 is 8,000. In my answer, I should have 8,000, and I do when it's written like this. If I just put 863 as my answer, it would be 800s, and 8 times 1,000 is not 800. So that's a good way to double check. Let's just do one more. Let's try, oops, why don't you go over? Get over there. I don't know why it's not, there we go. Let's do 0.42 times 1,000. All right. If I'm multiplying by 1,000, how many places do I need to move? 3. 3 for my 3 placeholders. Now I'm looking carefully. It needs to jump 3 times. 1, 2, 3. I tracked my 4 just to make sure that I was moving it 3 times exactly. Now I have 042. Is that my final answer? No. Again, there's nothing in the ones place, so I have to fill it with a 0. So does that mean my answer is 0420? Well, yes, but there's something there that I don't need to include. The first 0. Because there's nothing in the thousands place and it comes before the rest of my digits, I don't need to put it there. My answer is simply 420. Putting a 0 in the thousands place doesn't change anything. Putting that 0 in the ones place changes things. Otherwise, it would look like 42. So my final answer, 420. And you can double check by moving that decimal point or moving the decimal point. We know we don't really move it. I can't stress that enough. All right, on the screen, I'm going to pop up some questions for you to work on. They just simply have you multiply some numbers by 10, 100, and 1,000. Use the same strategy I used. You can move the digits over, or you can move the decimal place to find your final answer. Pause here and do your work in your notebook. Now let's try something a little bit more challenging. In a moment, I'm going to give you some problems where you're missing one of your factors. Now, the factors are numbers that you multiply to get your final answer or your product. In this number sentence, it shows me that something times 100 equals 64.2. How am I supposed to work that out? Well, I know the answer, so I can work backwards to figure it out. I can do the inverse. The inverse is the opposite. So what's the opposite of multiplication? It's division. So I have the number 64.2 at the end. And to get there, I would have had to move my number 2 places. Remember, the 2 places for the 2 placeholders, I would have moved it 2 places this way. So to get my starting point, I just need to move it 2 places back, or divide it by 100. So when we divide, we simply move the other way. So let me move it 2 places the other way to figure out where I started. 1, 2. 0, nothing, 0.642. My answer, 0.642. And I can double check that. If I have 0.642 and I move that decimal point, move it 2 places, 1, 2, I end up with the decimal point in between the 4 and the 2. And that's what I see here, 64.2. So I know that this is correct because it works going both ways. Let's try another one. $1,000 times some number equals 4,381. Well, I know where I end up. This is my answer, 4,381. So for me to figure out how I got there, I need to work backwards. So instead of multiplying, I'm going to divide. So instead, I need to divide it by 1,000, and for me to do that, I'm going to have to move 3 steps for the 3 placeholders. 1, I'm tracking that 1, 2, 3. Every digit moved 3 places the opposite way, so it got smaller. And my answer ended up being 4.381. Let me check if that makes sense. 4.381, if I multiply that by 1,000, I'm going to have to move that decimal point 3 times. 1, 2, 3. So the decimal point ends up there, behind the 1. And that's exactly what happens in this number, 4,381. The decimal point falls after the 1. So I know I'm correct. Now these are really simple once you know how to multiply, because all you have to do is be able to do the reverse in order to divide. So I'm going to pop up on the screen some questions for you that are very similar to this. It's either 10, 100, or 1,000 times some mystery number gives you a particular answer. And you're going to have to divide or work backwards to figure out what that factor, that missing number, was.
Pause here and do your work in your notebook.
All right, before I issue you your independent work, I want to take a quick look at a question that's very similar to the challenge you'll be getting. Let me erase this. This has nothing to do with it up here. Now, question 4 for your independent work is a table, and it's very similar to this. It has numbers along the top with some of them missing, as you see here, 2 blanks. And then it has operations along the side, but you don't know what the operations are. All you know is that you're multiplying by some number, and again, multiplying by some number. The way this table works is that you start with the number along the top, and you do the operation at the side to get the box below. So 0.62 times whatever this was gave 6.2. And 0.62 times whatever this is will give what goes here. So you have to line them up. It's a lot like a times tables chart. Now here I have some information filled in already, so that's going to help me figure out the blanks. For example, this one that I started with, 0.62 times something gave 6.2. Well, if I started with 0.62 and got to 6.2, I would have had to move 1 place this way. If I move 1 place this way so that the number gets bigger, I'm multiplying by 10. Remember I said I moved 1 place, so 1 placeholder. This helps me a lot because now I know to figure out the numbers that go up here, I need to multiply by 10. So let's do it for over here because I have a number up top here. 0.048. Let me go ahead and fill that in up here. 0.048. If I multiply that by 10, it's going to move one place this way. 0.48. There's my answer. Oops. Excellent. Now I can't fill in this one yet because I don't have a number up top. But for this one, I have the answer. And I know I had to multiply by 10 to get this answer. And we just did a bunch of problems like that. So instead of multiplying, I need to do the opposite. If I end up getting 5.8, and I did that by multiplying by 10, to find my starting point, I just need to go backwards. So I need to divide. 0.58. And that works going the other way. So if I have 0.58 and multiply it by 10, I get 5.8. Now this helps me even more because I can now use this to work out what will go down here. But before I can work out what goes down here, I need to figure out what this missing part is. Over here, I have all the information filled in. So let me use over here to work out what this was. 0.048 times this number gives 4.8. How many places did it move? Well, 0.048, and I had to get it over to 4.8. So let's move. Whoops, I wrote on the back of it. Oh man, I gotta start it again. 1 second. 0.048. This time my 8 will move. So I move it one place and I get 0.48, like I did right there. I move it another place and I get 4.8. So I had to move it twice. That's 2 placeholders. That means I multiplied by 100. Now that I have this, I can work out more of my table. 0.62 times 100. Well, I'm getting tired of using this, so I'm going to move my decimal point. It's going to move 1, 2 times my decimal point is going to end up there. So 62 decimal point, 62. All right, 58 times 100. Again, I've got to move twice. 1, 2. My decimal point is going to go to the end. 58. Now, my last thing to figure out is what goes in here. Now that I have this bottom number and I know what I had to do to get it. I had to multiply by 100. So let me work backwards. $34.2. If I'm going to work backwards, instead of multiplying, I need to divide. So I need to make my number smaller. So I'm moving it twice in the opposite direction. 1, 2. 0.342. That was the starting point, because when I take this number, 0.342, and multiply it by 100, I'll get 34.2. Now that I know my starting point up here, I can multiply it by 10 to get my last missing number. Well, to multiply by 10, it's just move in one place. So my decimal point moves once, and I end up with 3.42. So as you can see, to work out that table, it takes a lot of steps. You really have to think it through and look at what information you have and what you can do with it to figure out what you don't have yet. It's not hard, it's just a process. So don't go, Ms. Osborne, I don't get it, I'm going to skip it. No, you're going to do it because I just showed you how to do it. Take your time, you'll figure it out.
And now for your independent work. Today it's taken from pages 42, 43, and 44. I expect everybody to try everything up to question number 4 because I showed you an example of question number 4. If you find question 5, the challenge, a bit too difficult, ask an adult or a sibling for help, and even if then you can't figure it out, you may skip it. However, I do expect everybody to do that reflection. When you're done, take a picture and send it to me. As always, stay safe and I'll see you soon.